Very good morning, all. Hope nobody having any kind of network problem today. As we all know, today is very cloudy. Definitely, we'll have the network problem, but still, we'll hope for the good. And let me start this session. So, let me have a clarification whether my voice is audible to all. Was it clear? In this session, we are going to discuss about periodic classification of elements. Welcome all. Welcome for this session. Hope everybody can hear me. In this session, how the elements are classified. Who started classifying the elements? And how the periodic classification of elements attained a complete shape, and which one now we considered as a modern periodic table, who introduced, and trends of periodic classification. So all these concepts we are going to discuss in this session. Yeah, good evening all. A deep discussion on shopping mall. When we see the items which were kept in the shop, we feel very tidy, very clean arrangement, and very good classification. If we need anything concerned to the kids, we have separate compartment. For the adults, for getting groceries, etc., etc., everything it is kept separate, and we feel so easy in opting the things, right? And this classification is essential. If not, we feel very difficulty in selecting the objects in the mall. In the same way, in this nature, there are 108 80 elements are naturally occurring. I repeat, in the nature, there are 118 elements, among which 94 elements are occurring naturally, and rest of the elements are man-made or synthetic. Now, these elements should be arranged in a correct pattern. If not, it will become very difficult. Few having the network problem because of clouds, and few were not having the problem and they can hear me clearly. So, in the nature, we can see 118 elements, among which 94 are naturally occurring. rest are synthetic. Now, many people started dividing, classifying the periodic elements. And who is going to classify these elements? The ordinary man cannot do this. The scientist, the chemist. So they started grouping the elements. And while classifying the elements, a person called Johann Wolfgang Dobereiner, a German chemist, tried to arrange the elements with similar properties into groups. And he called that groups as triads. In this triad, he made 3 elements into one group. How many elements are there? How many total elements are existing now? Let me know. Total number of elements. I am waiting for your reply. How many elements are existing? Sometimes it happens. Let's see it simplified. Okay. Did you get any reply? How many elements are existing? Yes. How many are occurring in the nature naturally? How many are occurring naturally? Among 118, how many are occurring naturally? Yes, it is 118 elements in total. How many occur in the nature? Yes, it is 94. Absolutely correct. Good responses. Keep going. It is 94 elements exist naturally. Rest of the things are man-made. So in the Dobereiner, the person who grouped the elements according to the atomic mass. Dobereiner started classifying under one group. Is that clear? Yeah. Good responses. Into groups, and each group has 3 elements. And how he kept the elements in an order? He kept the elements in an increasing order as per atomic mass. As per atomic mass, in an increasing order, the elements made means that the atomic mass of the middle element was roughly the average of atomic masses of 2 elements. Now I'll show with the image. You just observe the image. From the University of Jena, and then he made Dobereiner used the law of triad. And these are some of the examples which shows the triad rule. What is the triad rule? The atomic mass of the middle element was roughly the average of atomic masses of other two elements. Look at first example, lithium, sodium, potassium. And look at the mass, 6.9, 23 and 39. Just add the first and third and take the average, and it is almost near to the middle, and this is the triad rule. Add the atomic mass of lithium and potassium, the average atomic mass of sodium. In the same way, other two examples, the atomic mass of iodine and iodine, and its average, it is the closest mass of bromine. So, like this, Doberina introduced law of triad. Law of triad. What does the law of triad explains? The atomic mass of middle element was roughly the average of the atomic mass of elements. Hope this concept is clear. Doberina triad rule is very important for your board exam, and there will be some numericals. There will be numericals on the law of triad. Okay, voice is not audible. Yes, when I share the screen, definitely you will have the audio problem. And what about now? It will be definitely network problem. Okay. What does Doberina's triad rule explains? Doberina's triad rule explains that the atomic mass of middle element was roughly the average of the atomic mass of other two elements. Okay, I'll repeat same example. Sodium, let it be A. Okay. Lithium, let it be A. Sodium, let it be B, and potassium A plus C divided by 2 is equal to C, that is sodium. I hope the example was cleared. I'll repeat once again. Lithium, sodium, potassium. Among these three numbers, lithium will be A, sodium will be B, and potassium will be C. Okay. And how to calculate? A plus C divided. Okay, how many of y'all can hear my voice? Give me thumbs up. Let me know. Is there any problem in the network? Can't you hear me? Because many of you are typing as not audible. Really, you are having the problem with the network? Yeah, Revati is not having any problem with audio. She can have good audio, right, Revati? And Priyanka having sometimes voices breaking. Okay. Nandita, yes. Okay, sometimes it happens because we started this session in the evening. Definitely we'll have this problem when we start at evening. And Basavaraj under name, she don't have any problem. She gave thumbs up. She can hear me. Okay. Till now we discussed about the law of triad. The law of triad was introduced by Doberiner. The law of triad says that the atomic mass of middle element was roughly the average of atomic masses of other two elements. By taking example like lithium, sodium, potassium, lithium considering as A, sodium as B, potassium as C. Now we want to find out B. How to find out B, the middle number? Take the average of first and third. That is A plus C divided by 2. We'll get the middle number. That is sodium mass will be obtained. Okay, this is about Doberiner's Triad Rule. So let me know whether Doberiner's Triad Rule is cleared. Should I repeat? Whether it is cleared or should I repeat? Repeat. Okay, it is cleared. Shall I go for next law? Yeah, Madhavi, she cleared with the concept, the law of triad. Yes, all of you cleared because we already discussed this session before last year. I don't know how many you all recall it. We completed this session last year. Okay. Okay. I'll go for next concept. If it is cleared, let me move to the elements as per atomic mass. It was not satisfied. Then the Newland, John Newland, an English scientist, again he started arranging the elements again based on increasing same way as Doberiner arranging the elements in order of the increasing atomic mass. Okay, Manasa want a repetition of Doberiner's law. Okay, Manasa, I'll repeat. Listen carefully. Doberiner introduced law of triad. What is law of triad? The law of triad was the average of atomic mass of first and third element. So there will be three elements, right? 1, 2, 3 or A, B, C. And what is the mass of B? First element mass, third element mass, add it and divide by 2. You will get average. And that average is equal to the middle element. That is equal to B. This is the law of triad. Is that clear, Manasa? Should I repeat once again? The law of is roughly the average of first and third element, and this law is referred as Dobrynin's law of Triad. Okay, let me go slow because audio problem. Okay, let me go slow. Now next rule is Newland's law of octaves. The Newland, when he started classifying the elements, at that period 56 elements were discovered. He started arranging the elements in order of increasing atomic mass. He considered hydrogen at lowest atomic mass and thorium as the last element. So he arranged 56 elements in such a way that he arranged the elements from 1 to 7, and the 8th element will come under the first element. 1, 2, 3, 4, 5, 6, 7. After 7, 8 will come below the 1. Is that clear? Is that clear? The concept is clear? And they found that showing similar properties. The same properties. But the demerit of this Octaves law is it can hold good till calcium only. After that, the law of octaves doesn't succeed in the explaining the properties. Okay, if you are having the network problem. Now what about law of octaves? Should I repeat? Okay, let me share the screen. You just have the view on the periodic table created by the Newland. This is the Dobrynin 23, potassium 39.1 plus 39.1, and that will be divided by 2. La. And elements are there: hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. How many are there? 1, 2, 3, 4, 5, 6, 7. Okay. So he kept 7 elements in one row, and the 8th element comes below. Fluorine comes hydrogen. Elements in an order of increasing atomic masses, and he kept the 7 number elements in one row, and he kept 8th element below the first element. And the properties showing like lithium and sodium, same properties. Beryllium, magnesium, same properties. Boron, aluminium, same properties. Right? So it was good till calcium. Till calcium. After magnesium, you can see calcium. Now the principle will holds good till calcium. But after calcium, he comes with other elements. So Even the law of octaves got failure. Okay, the concept is clear. He introduced in 1865, arranged the elements according to increasing atomic masses with similar physical and chemical properties, but it holds good till calcium, but not after calcium. So the Newland Octaves law got failure. So Octaves law can be applied till calcium. Newlands arranged about 56 elements in his periodic table. He arranged 7 elements in one row and 8th element below the first element. He same slot, the mistake done by the elements showing similar chemical and physical properties, and hence the law of octaves became failure. And then resistance. Mendeleev's periodic table was quite improvised, arranged the elements, about 63 elements, and he was quite confident in classifying. He selected oxygen and hydrogen, and he made other elements to combine with oxygen and hydrogen so that the hydrides and oxides are formed. Based on that, he tagged the elements with showing similar physical and chemical properties. As a result, he made the periodic table into vertical columns called groups, horizontal rows called periods. So this is the Mendeleev's periodic table. Now you count the vertical columns. How many columns are there? Count it. Later I'll ask the question on this. How many vertebral columns are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertebral columns are there. Okay. How many horizontal lines are there? 1, 2, 3, 4, 5, 6 horizontal rows are there. Okay. Cleared? Have you all gone through this table? Count the vertical columns and horizontal rows. You all just saw the Mendeleev's periodic table, right? Okay, my question is, columns called as what? Yeah, correct answers. Good. Yes. Now my next question is, what is the name given for vertebral columns? Vertical columns. What is the name given for the vertical columns? My question is, What is the name given for vertical column? Yes, it's Revati and Priyanka answered. The vertical columns are called as groups. Very good. Yes. How many groups are there? How many groups are there as per Mendeleev's law? Yes, it is groups. Correct. Correct answer. How many groups are there in Mendeleev's periodic table? Yes, correct answer. Good reply. Now, what is the number of groups? Yes, it is 8. All of you answering correctly. Very good. Okay, Kavya got confused. We don't call horizontal groups. We call vertical columns as groups. My next question is, what is the name given for horizontal rows? What is the name given for horizontal rows? For your reply, what is horizontal rows called as? Priyanka Varsha, correct answer. It's periods. Yes, all of you answering correctly. Remember, the vertical columns are called as groups. The horizontal rows are called as periods. Okay. How many periods are there in Mendeleev's periodic table? How many periods are there? Correct answer. How many periods are there in Mendeleev's periodic table? Yes, it is 6. Correct answer. There are 6 horizontal rows found in Mendeleev's periodic table. This was an excellent work. The Mendeleev classified based on the formation of oxides and hydrides. He made element to combine with oxide and to combine with hydride, oxygen and hydrogen. Then he found that the formation of oxides and hydrides, and later based on that he classified the elements into 8 groups and 6 periods. Remember, this will be very important for your NTSC exam and also for your board exam. Okay. And what is the improvements compared to the Newlands? In the Newland, cobalt and nickel were kept in same plot, right? In the previous one. Okay. In Mendeleev's, cobalt appeared before nickel. It was kept separate, but cobalt appeared before nickel. This was an improvised sequence in Mendeleev's law. And while Mendeleev started blank, which were not discovered, this becomes a clue for many chemists to identify, to discover the new elements. As a result, the noble gases like helium, neon, argon, and these noble gases were discovered as a result of Mendeleev's periodic table. Is that cleared? Mendeleev's periodic table? Anything to be clarified here? If it is cleared, we'll go for next limitations. Till now, we come to know there are certain advantages and still we have disadvantages of Mendeleev's classification. What were those disadvantages? Again, as Newland, Mendeleev also classified the elements according to their increasing atomic mass. Atomic mass. That was a mistake done by the Mendeleevs. Why? There may be existence of isotopes. What are isotopes? Isotopes are the elements having same atomic number but different atomic mass. Isotopes are the elements having same atomic number but different atomic mass. So if isotopes are existing, so for each element, Mendeleev has to give more boxes, more placement. So the periodic table become very enlarged. This was a disadvantage of Mendeleev. So it should be improvised. So let me have the glance upon the table. Once again, Mendeleev's table. Of Mendeleev's periodic table, many new chemicals came into existence, like existence of noble gases like helium, neon, argon came and entered. And there are certain disadvantages also. What does Mendeleev's periodic table, periodic law states? The physical and chemical properties of elements are the periodic functions of atomic mass. Hence, this was a limitation. This was a disadvantage. This is disadvantage because isotopes are existing. What are isotopes? For phosphorus, we have to give more boxes because they have isotopes. Same atomic number but different atomic mass. So this was a limitation. And position of hydrogen was not clearly defined. And lighter elements were placed after heavier elements. This is not accepted. Isotopes' existence brought confusion. In order to keep the elements place were kept in different groups. This was another disadvantage. And periodic table did not affect electronic configuration. So these were the disadvantages of periodic table. Continued, and that is Slay gave modern table. Okay, this is the modern periodic table. Now, in the modern periodic table, again, I'm going to give exercise for you all. Count the vertical columns and count horizontal rows. Count vertical columns and horizontal rows clearly. Okay, you all gone through the modern periodic table? All of you gone through the modern periodic table? Now tell me, how many groups are there? I mean vertical columns. How many periods are there? I mean horizontal rows. Yes, Revati answered as 18 vertical columns. Correct answer, Revati. 18 groups are there. Yes, it is 7 periods, 7 horizontal rows, and 18 vertical columns. And 7 horizontal rows called periods, 7 periods. And other than that, at the down of the periodic table, again we find 2 horizontal rows, and those are referred as lanthanides and actinides. Lanthanides and actinides. Why this variation? Why we find such variation? Among 18 vertical columns or the groups, they show similar physical and chemical properties along the group. Along the group in the sense, they show similarities along the vertical column. But the lanthanides and actinides were kept separately because only these 2 horizontal rows shows similar physical and chemical properties in horizontal row wise. They show similarities along the row, not according to vertical column. Hence, they were kept separately. Was the concept clear why the lanthanides, actinides kept separately in the periodic table? Was the concept clear? The lanthanides, actinides existence make the periodic table to break as all the elements in the periodic table shows similar properties as per vertical column, but lanthanides and actinides show similarities along the horizontal rows. Hence, the periodic table looks broken. Okay, this is an area where the questions may rise for your board exam. Here they show the similarities along the horizontal row, not according to the vertical column. Lanthanides are the elements which starts from the atomic number 58 to 71, and they were kept separately. Actinides, these were the elements which starts from the atomic number 90 to 103. They were kept separately. They were kept separately because lanthanides and actinides show similar properties along the row, not along the column. Hence, they were kept separately. And very, very important advantage of modern periodic table is the modern periodic table is applied like this. The properties of elements are the periodic function of their atomic number. Here, the properties of elements are the periodic function of their atomic number. Here, Moseley applied the atomic number keeping the isotopes in his brain. In order to solve the problem of isotopes, he made based on their. So this was a successful concept of Henry Moseley in order to avoid the concept of isotope. The classification is based on atomic number and easily arranged in order of increasing atomic number. He grouped the elements based on similar physical and chemical properties, which were arranged into 18 groups and 7 periods, where actinides were separately because they show properties along the row rather than vertical column. He classified the elements into 4 blocks: S, P, D, F. S, P, D, F. 4 blocks. So, you all know what is the concept of SPDF. Look at the first 2 groups. Only look at the first 2 groups. Group 1, Group 2. Group 1 is hydrogen. Group 2 is beryllium. Look at these 2 groups. These 2 groups are called S block. Okay. Next, come to the group 13, 14, 15. These groups are called P block. P block. Next, look at the group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. From group 3 to 12. These groups are called as D block. D block. And come to the lanthanides and actinides. How many rows are there? 2 rows. And these are called F block. These are called F block elements. So these are the merits of modern periodic table. Hope the concepts of Moseley's modern periodic table was cleared. How many blocks are there? How many blocks are there? How many blocks are there? the 4 blocks. Put the letters in capital form. Yes, it is SPDF blocks, correct? Yes, only 2 girls were answered. SPDF, correct answers. Okay, so many answers. Right. Correct answers. Okay, now these SPDF blocks are completely based on electronic configuration. The blocks were classified based on the electrons number. What is the limit of electron number of P block? Remember, it is 2. And next is S. What is the limit number of P block? It is 6. And what is the limit number of D? It is 10. And what is the limit number of F block? It is 14. Can any one of you tell me how this number came for S2, for P6, for D10, for F14? How these numbers was given to SPDF block? If anyone ready to answer this? How these number become the limit number? Yes, Kavya, correct. There are 4 blocks SPDF, and also I gave the number. For S it is 2, for P it is 6, for D it is 10, for F it is 14. How this number has come? Okay, this limit number is, the reason is very simple. It is the number of groups. Now look at the modern periodic table. How many S block groups are there? How many S block? Group 1, group 2. There are 2 groups under S block. Hence, the number for S is 2. How many groups are found in P block? Kirti, counting the number of groups, we'll get the number for SPDF. Very good answer, Kirti. Groups. Yes, Arpita answered correctly. It is 6. For P block, there will be. And what about D block? What is the maximum number of D block? Yes, Kavya, correct. Counting the group number. Very good answers. You all got the idea. Very nice. What is the number for D? D block elements. Yes, it is 10. Few answered 6. 6 is wrong. 10 is correct answer. Yes, many of you are answering correctly. It is 10. Very good answer. And finally, what is the number of F block elements? Yes, it is Gangotri answered 14. Very good. Answer. Gangotri, Priyanka, Kirti. Everyone answered correctly. It is 14. Okay. Now, the modern periodic table is based on completely electronic configuration. Now, if you look at the groups, you just observe each group. Every group were arranged by increased one number of proton or electron. When you count down the group, one electron or one proton will be increased. And in the same way, along the period, if you go along the period have same subshells. It is having same subshells. They are having same energy level shells or subshells. Now, how to write electronic configuration? 1s2, 2s2, 2p6, 3s2 and so on and so on. Now, 1s2. Now, if you take hydrogen, the atomic number is 1, right? Now, how to write electronic configuration? I'll give an example. It has got only one electron. So, the electronic configuration is 1s1. 1s1. Now, tell me, what is the electronic configuration of helium? Yes, Priyanka answered 1s1. Very good answer, Priyanka, for hydrogen. Now, I already posed the question for helium. Raghavi. Yes, Priyanka answered 1s2. 1s2 is the right answer. 1 is 1. So, we have configuration by 1s1. And for helium, it is 1s2. Number is 2 filled. Now, even though helium has got electrons, it is kept in the group 18th group. Remember, 18th group, that is helium, neon, argon, krypton, xenon, radon, right? All these elements are called zero group elements, noble gases. They are called zero group elements. Zero group elements. Remember, 18th group elements where we see helium, zero valence group. And octet structure. Octet structure means 8 electrons in outermost orbit. Outermost orbit. When it attains octet structure, they remain stable. Their valency is 0. They are completely inactive. They are completely stable, hence they are inactive. Okay. All elements got octet structure. What about helium? The electronic configuration is 1s2. Only 2 electrons. But still, the s block is completed. Right? What is the maximum number of s block? It is 2. Hence, even that is 0 group element, stable. It has got 0 valency element. Cleared? Yes, all of you answering correctly. Very good responses. Hope you all remember last year's session. Everybody remember last year's session? Everything I covered in the last year's session. Yes, very good, Priyanka. And many of you all answering correctly. No confusions. Because this session is so tough. You can't understand in a live session. It's so tough. But still, your responses is so good. Now everything it is cleared. Then only I am getting very good responses. Right? Okay. Now, let me move on to the trends in modern periodic table. What are the trends in modern periodic table? Here, we are going to know the terms like what is valency, what is atomic size, what are metallic and non-metallic properties of periodic elements, and also electronegativity. Now, let me know what is valency. What is valency? The valency of element is determined by the number of valence electrons present in the outermost shell of its atom. Now, hydrogen. What is the number of outermost orbit? What is the number of outermost orbit in hydrogen? What is the number of electrons present in outermost orbit of hydrogen? I am waiting for your reply. Yes, Priyanka, absolutely correct. It is 1. Hence, 1 is the valency of hydrogen. Kitty, where you are? You answered as 2. It is only 1. Okay. So, what is the number of electrons present in the outermost orbit? And that is the valence electrons. That is the valence electrons. Okay. The valency of element is determined by the number of valence electrons present in the outermost shell of its atom is known as valency. And what is atomic size? What is atomic size? The term atomic size refers to the radius of the atom. Radius in the sense from the center of the nucleus to the outermost orbit. The radius of the atom. The atomic size usually decrease along the period, increase down the group. Remember, the atomic size decrease along the period, increase down the group. Why the atomic radius decrease along the period? Remember, when the elements moves from left to right side of each period, the number of electron will be increased by 1. From one box to another box, the number will be increased by 1 electron. But where that electron exists? That electron exists in a same shell, in a same subshell. Throughout the period, the added electrons will remain in a same shell, hence the atomic radius decreases and increases down the group. Is that clear? Is that clear why the atomic radius decrease along the period and increase down the group? Want me to repeat? Okay, all of you cleared. I'll repeat once again. The atomic radius decrease along the period and increase down the group because when we move from one element to another element, the number of electron increase by 1 and hence the atomic radius decrease. Okay. And what are the metallic and non-metallic properties of the periodic elements? When you see the elements towards the S block, that is sodium, magnesium, zinc, all these called as metals. When you move towards the P block, the elements will be non-metals. Towards the S block, they are called metals. Towards the P block, they are called non-metals. The metallic nature, you just look at the metallic nature. Towards the left, it is more, and towards the right, non-metallic nature is more. And this is because the valence electrons increases across the period. The valence electrons increases across the period and the tendency to lose the electron will decrease. And hence, towards the left, we find property. Some other elements other than metals and non-metals. Those are semi-metals or metalloids. They are called as close the door. Along the left, I said metals. Along the right, I said non-metals. And other than this, we have metalloids. And metalloids are called as semi-metals. What are semi-metals or metalloids? Metalloids which exhibit both the characteristics of metals and non-metals and hence called metalloids. So these are borderline elements which act as intermediate between metals and nonmetals, and those are called metallites. Okay, this about the trends in modern periodic table and how we can find out the valence electrons by counting the electrons at the outermost orbit, and how to know the atomic radius, whether it decreases or increases, where it decreases, if it increases, where it increases. Along the period, atomic size increase, down the group, it increase. And in the periodic table, we find metals, nonmetals, and metalloids. Metals always positive ions by losing the electrons. Nonmetals attains negative ion by gaining the electrons. The metalloids, which having the property of both metal and non-metals, and hence they are metals. So these are the important trends of periodic table. I hope everybody cleared with this. Anything to be clarified here? Anything to be clarified here? Okay. If it is cleared, you just answer for this question. Give example for metalloids. Okay, I already posed the question. Give example for metalloids. Give example for metalloids. Good, Priyanka. Okay, not clean group. The valency is, remember, okay, don't, and E. It is 4. Valency is 4. 5th group. Four, we have to go down. That is 3. 16th group is 2. What kind of 2 here? 3, minus 3, minus 2, and halogens group, 17th group, it is minus 1. Do you know how this number has got? Nitrogen outermost orbit has 5 valence electrons, right? Nitrogen will have 5 valence electrons. After 4, we have to minus. Now, it is more than 4, that is 5. That is, nitrogen has got 5 valence electrons. Minus 5 from the 8 octet number. If you minus 5 from the 8, we'll get minus 3. And 6, outermost orbit has 6 under oxygen group. That becomes minus 2. And fluorine, chlorine, outermost orbit will have 7 valence electron. And here we'll consider it as minus 1. And the last 18th group, 0 valency. I hope it is cleared. Now I'll pose the questions. I'll mute it and only silent answers. Strontium. That. Now come 13th. All carbon. Now after 4, you don't go for 5. You go for decreasing order. Okay. After 4, minus 3. Nitrogen will have minus 3. Next, oxygen, minus 2. Fluorine, minus 1. Okay. 17th group will have 1. And the last one, 18th group, it is 0 group. Okay. Now it's clear. After 4, you have